This is section 8.1 on arc length. So what we're looking to do is we're looking to find the length of this curve, but we don't know how to find lengths of curves. We only know how to find lengths of segments. So we're going to break the curve into small partitions or small segments and add them all up. So we know that the distance formula between 2 points is given by this formula. And so we just need to take the limit as n approaches infinity of those segments. And so here's the formula for arc length. It turns out to be this formula. So what we need to find is find the function and take the derivative of it and then square it and then add 1 and then take the square root and then we can integrate. So for this first example, we need to find the exact length of this curve between 2 and 3. So let's solve for y first. We can do that by dividing by 36. We get y squared equals 1 over 36. Y squared minus 4 to the third. We can take the square root or raise both sides to the 1/2. That's the same thing. And so we end up getting y equals, and because we're dealing with positive y values, we only have to worry about the positive root, not the negative. So this becomes 1/6 x squared minus 4 to the 3/2 power. And now we can take the derivative, which would be, let's see, that's going to be 1/4 x squared minus 4 to the 1/2. And since we're going to need to square it for the formula, let's square it now and then just substitute it into the formula. So y prime to the second power will be 1/16 times x. Oh, I forgot to take the chain rule. Don't forget to take the derivative of the inner function, which is times 2x. This becomes 1/2. Sorry about that. So now let's fix this derivative. The derivative is squared now. When you square that, that's going to become 1/4 x squared minus 4 times x squared. Now if we distribute the x squared and the 1/4, we should get 1/4 x to the 4 minus x squared. Okay, so we finally found the derivative squared. Now we can plug it into here. So the arc length becomes the integral from 2 to 3, since those are our limits that are given, square root of 1 plus derivative squared. And most of the time, if not all the time, if you have 3 terms, a trinomial, then you're going to be able to factor it into a perfect square binomial. So we can factor that. If you factor that, it's going to turn out to be 1/2 x squared, minus 1 to the second power. Yeah, that's what it's going to become with respect to x after you factor this trinomial. And then you would get, well, because we're dealing with positive values, you can cancel the square and the square root. And that's going to be the integral from 2 to 3 of 1/2 x squared minus 1. And now the antiderivative will be 1/6 x cubed minus x from 2 to 3, which is going to be, let's see, if you plug in 3 and then 2 and then you subtract, you should get 13/6. That is the final answer. All right. Let's look at the second example. So same thing, we're gonna take the derivative. We don't need to solve for y because it's already solved for. So all we have to do is take the derivative, which would be 1 over cosine of x times the derivative of cosine, the chain rule, negative sine of x. And that, by definition, is negative tangent of x. And since we need to square the derivative, we might as well square it now. When you square negative tangent x, that's just positive tangent squared x. All right, now we can plug it into our arc length formula. We're going from 0 to pi over 3. That's going to be the square root of 1 plus tangent squared of x with respect to x. This should look very familiar to you. We're going to be using an identity. The identity is 1 plus tangent squared x equals secant squared x. So we're going to do the substitution in here, and that's going to give us the square root of secant squared x. And as you can see, we're in the first quadrant. Secant is positive in the first quadrant, so we don't have to worry about negative roots in this case. It's just positive secant x. And if you recall from the section 7.5 where we're given a table of formulas for integrals, this was one of them. And the antiderivative of secant turns out to be natural log of secant x plus tan x. And we're going from 0 to pi over 3. If you substitute those values, you should get well, tangent of 0 is 0, secant of 0 is 1. The natural log of 1 is 0, so this entire term cancels out. And the secant of pi over 3 is 2, and the tangent of pi over 3 is radical 3. So our final answer is going to be the natural log of 2 plus radical 3. Sorry, I had to squeeze that in there. So it's just the natural log of 2 plus radical 3. There it is, natural log of 2 plus radical 3 is our final answer. All right, the next example involves x. The function is x in terms of y, and so the formula is going to be the same for the arc length. The only thing is that the roles of x and y have been interchanged, so now you're going to take the derivative of x with respect to y and then integrate with respect to y. So everything basically is the same. So we can leave our function the way it is. We don't need to solve for y, which would be very difficult in this case. So what we're going to do is just take the derivative. You can call it x prime, or you can call it dx, dy if you wish. Same thing. This is going to be 1/2 y cubed. I'm going to rewrite this term as 1/4 y to the negative 2 to make it easier to differentiate. That's going to become negative 1/2 y to the negative 3. Squaring that will give us, what is that going to be, 1/4 y to the 6. That's going to become, let's see, that's going to become negative 1/2, and that's going to become positive 1/4 y to the negative 6. You can verify that. If you square this binomial, you will get this. So now we can plug it into our formula for arc length. We're integrating with from 1 to 2 square root 1 plus the expression that we just came up with. With respect to y, combining like terms, that means we can combine the 1 and the negative 1/2. That's going to be positive 1/2. And like I said earlier, this will always be a perfect square binomial when you have 3 terms like that for these type of problems. And if you factor that, you're going to get 1/2 y cubed for the first term, and positive 1/2 y to the negative 3 for the second term. And you will see that that does indeed, if you expand that out, will give you that expression. And once again, we are dealing with positive values here. So the root, we only have to worry about the positive root, not the negative. So those cancel. And now we have 1 to 2, 1/2 y cubed plus 1/2 y to the negative 3 dy. And now if you integrate, you find the antiderivative, you should get, what is that going to be, 1/8 y to the 4th. minus, that's going to be 1/4 y to the negative 2. We're going from 1 to 2. Plugging that in gives you 16/8 minus, what's that? That's going to be 1/16 minus, plugging in 1 gives you 1/8 minus 1/4. And then 16/8 minus 1/8 is 15/8. And to combine these two, I'll have to multiply top and bottom of this by a 4 to make that 16. So that's going to be a positive 4/16. Take away 1/16 is 3/16. All right, and the common denominator is 16. That's going to be 30 plus 3 is 33/16, which is our final answer.